Fermi Paradox is known for posing a direct question about extraterrestrial life. It centers on the apparent contradiction between the high probability of advanced civilizations existing elsewhere in the galaxy and the lack of observable evidence or contact. The paradox draws from established scientific estimates that suggest the Milky Way contains billions of planets, many of which might offer conditions suitable for life. In 19B, physicist Enrico Fermi, during a casual conversation over lunch, raised a question that would later define the paradox. If advanced extraterrestrial civilizations exist, why have they not revealed themselves or visited Earth? His remark occurred during a time when Earth had only recently begun to understand nuclear forces and contemplate space travel, and it came as a simple, straightforward inquiry rather than a grand pronouncement. Michael Hart's 1975 paper outlined potential reasons why extraterrestrial life might remain unseen. He considered travel obstacles, cultural choices against colonization, the possibility that no civilizations had the time to reach us, or the notion that any past visits had gone unnoticed. Frank Tipler, in 1980, built upon these ideas, exploring the concept of self-replicating probes and suggesting their absence in our observations. These arguments, published in peer-reviewed scientific literature, framed the paradox within known physical laws and engineering concepts. Large-scale attempts to detect extraterrestrial signals have occurred. In 1960, Project Ozma used a radio telescope in West Virginia to listen for signals from two nearby stars. In the following decades, the Arecibo telescope in Puerto Rico and the Green Bank telescope in the United States scanned the skies. The SETI Institute organized systematic searches, including Project Phoenix and the Allen Telescope Array, all directed toward detecting artificially generated radio signals. These efforts consistently returned silence, which fueled discussions about why no transmissions or engineered patterns appeared in the data. Astronomers have discovered a rapidly growing list of exoplanets since the 1990s. With each year, more planets join catalogs, revealing a broad range of worlds orbiting stars with different sizes, temperatures, and chemical compositions. Instruments like the Kepler Space Telescope and TESS have revealed that Earth-sized planets are not rare. This information has led researchers to estimate that many planetary systems could host conditions suitable for life. Wide-field surveys and advanced spectroscopic techniques have confirmed the ubiquity of these worlds, yet no confirmed signals from intelligent life have emerged. I remember standing behind a small amateur radio dish on a cold evening, aiming it at a section of sky mission stars. I adjusted the receiver and waited, expecting at most a faint whisper or an anomalous pulse. Instead, static hissed across the speaker. It felt odd to point a device into the darkness, anticipating something crafted by distant minds, and finding only a quiet rush of background noise. The equipment recorded numbers, lines, and spikes in signal strength, all analyzed later. The result revealed natural cosmic phenomena, pulsars chirping, hydrogen clouds glowing faintly. There were no unmistakable engineered patterns. Some scientists have considered the idea that intelligent life might be extremely rare. Others have focused on timescales and the possibility that civilizations arise and decline too quickly for their signals to overlap. Another set of proposals emphasizes that alien civilizations might be uninterested in outward contact or may choose to remain silent. Certain hypotheses suggest that life could be hidden under ice-covered oceans or locked deep beneath planetary surfaces, never becoming visible from afar. Still, these are all discussed as hypothetical considerations rather than confirmed facts. In the late 1970s, the WOW signal, a sudden, unexplained spike in a radio frequency band associated with extraterrestrial searches, caught attention. The brief signal, recorded by Ohio State University's Big Ear Radio Telescope, came and went without repetition. Data records showed an unusual intensity that matched none of the known Earth-based or cosmic background sources. Subsequent follow-up searches failed to detect it again. The event entered the archives as a curious anomaly, factually documented but unresolved. During the Cold War era, both the United States and the Soviet Union launched probes beyond Earth's orbit. Pioneer and Voyager spacecraft carried plaques and golden records illustrating Earth's location and the diversity of its life. These items were placed aboard as factual attempts at interstellar messages, though none have yet encountered any known recipients. The spacecraft still drift among cosmic rays and interstellar dust, carrying their information through silence. In the past decade, newer instruments such as the Square Kilometer Array, currently under development, promise more sensitive searches for faint signals. Spectroscopic studies of exoplanet atmospheres have begun to detect chemicals like water vapor and methane on distant worlds. These discoveries are recorded in scientific databases and confirmed through peer review. They enhance knowledge of planetary diversity, with certain atmospheres suggesting conditions that could support microbial life. Yet no confirmed indicators of advanced technology have surfaced. I recall visiting a large optical observatory high in the Andes. With careful alignment, a telescope mirrored the starlight of distant suns onto detectors sensitive enough to catch tiny dips in brightness as planets passed in front of their stars. The equipment functioned precisely, the data arriving as clear numeric values. Analyzing those values indicated new planets, but no engineered structures or artificial emissions that would confirm intelligent beings. Researchers stored the results in computers and published them, noting each discovery without finding signals of technological complexity. Scientists like Jill Tarter, associated with the SETI Institute, have spent careers scanning the skies. They have searched wavebands, tested frequency ranges, and developed algorithms to spot patterns. They have found pulsars, quasars, magnetars, supernova remnants, molecular clouds, and gravitational lensing events. All these phenomena were documented in observations and papers. The datasets remain publicly available for others to inspect. No confirmed extraterrestrial communication signals have appeared in these surveys. Some consider the Drake equation and the Seeger equation when estimating the number of detectable civilizations. Variables in these equations are based on measured values and educated guesses. They quantify star formation rates, planetary abundances, and the fraction of worlds that could host life. They consider the likelihood of intelligence and technology arising. None of these equations produce definitive answers. They simply represent attempts to frame the question with known parameters. During a drive through a desert region once, I saw a radio telescope array pointing upward. Its large, pale dishes contrasted with the brownish landscape. Workers in protective gear performed routine maintenance. Cables and computers control the direction of these dishes, recording cosmic static and occasional bursts of energy from distant galaxies. The results went into server full of raw data. Analysts filtered out terrestrial interference, satellites, and known astrophysical phenomena. After careful checks, nothing indicated a distant civilization's deliberate broadcast. This situation has not changed since these activities began. Observations pile up, instrumentation improves, and catalogs of exoplanets expand. Space probes continue their journeys. Radio telescopes refine their searches. Pulses from magnetars and neutron stars get cataloged. Observers in many countries publish their findings. The official records contain star positions, spectral lines, periodic dips in brightness, and energetic flares. They report measurements of exoplanetary atmospheres and the presence of molecules associated with biological processes. The results confirm the complexity of the universe's chemistry and the abundance of planetary environments. The Fermi Paradox, defined as the discrepancy between high estimates of extraterrestrial civilizations and the absence of contact or evidence, remains documented in scientific literature. It appears in textbooks and research papers, repeatedly stated without resolution. Data show that telescopes aimed at the sky have not captured signals that can be definitively attributed to advanced life outside Earth. Observers continue to gather information, store it, and compare it with previous records, noting incremental progress in understanding star systems and planetary conditions. Modern researchers studying exoplanets often reference equations that model biosignatures and technosignatures. They have proposed that future observatories might detect industrial pollutants or artificial lighting on distant worlds. So far, no confirmed detection of such features has been made. The ongoing assessments remain recorded as a series of known measurements and documented analyses.